Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your genes. I'm Ian Woolf. On this edition, Angela Crean talks about non-genetic inheritance and Luke Coffey builds a robotic guitar. The news, good and bad, returns next week. Sex and reproduction are not necessarily as straightforward as you may have been led to believe. We know the environment a mother lives in can affect the health of her babies, but what about the father's environment? Does the social environment play a part? Are there mechanisms for inheritance other than genes? Dr. Angela Crean is an evolutionary ecologist in the Sydney School of Veterinary Science at the University of Sydney. I began by asking her, is her speciality sexual selection within evolutionary ecology?
Yes, I'm really interested in how a male's environment influences his sperm quality and whether changes in sperm quality influence offspring quality.
And what sort of environmental changes have you found make an effect?
The two environments that I really focus on are diet, because that's a bit of an obvious one. We know that diet has really strong effects on female reproduction, and there is emerging evidence of similar effects on male reproduction. But the other one that I find really fascinating, that is less well recognised, is effects of the social environment of the male. So whether he has a lot of competitors around or whether he doesn't have to try very hard to get the ladies.
And what is the effect?
So there's this mechanism that is very well known in evolutionary ecology called sperm competition. And it's the idea that the fight to get offspring doesn't stop after you've managed to get a mate. If that female has mated with other males, then the male sperm has to compete against those sperm to get the egg. And we find across the animal kingdom this very strong response to that cue of sperm competition. If the male receives a signal that his sperm will have to compete, then he usually produces better quality sperm and more sperm. And I'm wondering if we can leverage that response to try and influence success rates in things like artificial reproductive technologies.
And we know from previous research that this applies to humans, that we've evolved to have different types of sperm, including competitive sperm, if we know our partner may have had sex with other males.
We do have some suggestions. It's not so clear-cut, but there is definite indications that similarly in humans, males will produce better quality sperm when they have a cue of sperm competition. Now, it's a little bit controversial because obviously the response is that humans don't have a lot of sperm competition. There's not, we typically live in a fairly monogamous sort of relationship. But because this is such a conserved response over such a long time, the response can still be there in the male, even if the females are not actually mating multiply that common. The selection pressure is so strong to not get outcompeted that even a really small proportion of the population mating multiply can continue that selection pressure to make sure that the males can still respond.
And so how do you test this?
Excellent question. How do you test it? Well, that is something that I've been trying to work on. But there's a very interesting study that was done a few years ago now at the University of Western Australia. And they got males to provide samples, semen samples, either looking at images of just females or images where you had 2 males with a female. So obviously with the 2 males, we're expecting they're getting a cue of sperm competition. And sure enough, when they tested the sperm quality, they found that the sperm were more motile when males were viewing images of multiple males that they would be competing against.
And so motile means they move faster?
Yes, so, well, there's 2 terms. Motile is generally refers to the amount of sperm within an ejaculate moving. We can also test for sperm velocity, how fast those sperm are swimming. And they're 2 quite common measures that you would get assessed in an andrology clinic when you were going to get your sperm quality tested.
And are faster sperm better sperm for offspring?
Are faster sperm better? Intuitively, of course, you would say yes. I have done an experiment in the past with sea squirts that actually found slower sperm produced better offspring. So the faster sperm were able to get the eggs, but if you just took those fertilized eggs to track the success of hatching, the eggs from the slower swimming sperm were more likely to successfully hatch out into larvae. So it might be a trade-off situation where if you're fast, you can get there, but maybe not as careful with the development. Whereas if you go slow and steady, you don't always win the race, but you make sure you have a really high quality product at the end. I can't say whether the same thing is found in humans, of course, but it is something that I'm hoping to look into.
So for couples trying to conceive, what should they take away from the research?
I'm not sure that I would like to provide any recommendations as of yet, but something that I think is really important to keep in mind is that a male's environment does influence his sperm and does influence his offspring. So we have a lot of attention given to females, given advice not to drink, not to smoke, eat certain foods, of course, while you are pregnant, but even when you're trying to get pregnant. But we often don't give the same advice to males. And I think it's really important to get that message out there that yes, perhaps they should be thinking about how they're living their lifestyle before they actually conceive.
So what sort of effects have you found on a man's environment can have this sort of detrimental effect?
I haven't done any work in humans as of yet, but some of the effects that have been found are with obesity. It's a bit varied. Some studies have found that a high-fat diet does have a negative influence on sperm. Some studies don't find that relationship. Of course, as we said, it's a lot more difficult in humans because we can't do these highly controlled experiments with the same numbers that we can in animals. But we also find effects of alcohol, obviously.
And previous partners can actually matter.
Previous partners has been some of my most controversial research to date, but I was working with Nereid flies and we were testing whether these paternal effects that we'd seen, the effect of a father's diet on his offspring, were transmitted in the sperm themselves or something else within the seminal fluid. And so we ran an experiment where we mated the females while she was still immature to either a large male that had been fed lots of food or a small male that had a restricted diet. And the idea of mating when she was immature is we thought that any components in the seminal fluid might be able to be absorbed into her developing eggs, but they won't actually fertilize the eggs yet. 2 weeks later, we then remated the females once again to either a large or small male, and this second male fertilized those eggs. But when we looked at the size of the offspring, what we found was that was affected not by the father, but by that first mate of the female. And checked the data and double-checked the data, and then tried it again and found the same response. And so what we think is going on is that it's something else within the seminal fluid that is getting transferred to the females, changing the development of her offspring, so that you can find effects of a previous mating partner who's not the father, but he can pass his condition on to the female's future offspring.
Is it seen outside of the nereid flies?
So far, we have also seen similar effects in Drosophila, fruit flies, and I have reviewed some research that is finding it in other insects. We haven't scaled it up, but some of my future research is hoping to test for similar effects in mammals. Now, obviously, reproduction in insects is quite different to in mammals. We have different processes happening with the eggs in the development. So no, we don't know, but I think it's entirely possible that seminal fluid will influence other offspring.
Wasn't there a historical case that was highly suggestive?
The case of Lord Morton's mare. I came across this when I was looking for similar effects and found this phenomenon called telegony. And it all is based around this idea of Lord Morton's mare who was mated to a quagga. Quagga is similar to a zebra. And so trying to conserve the quagga, they mated to a pure stallion. And then when they found later pregnancies from this stallion to normal stallions, the offspring would come out with these stripes and this stiff mane, just like the original quagga. And if you look back at the science at the time, any theories of inheritance, they hadn't discovered genetics yet. They were still trying to figure out how traits were passed from the parents to the offspring. And at the time, anyone proposing a theory of inheritance had to explain how this occurred. Now, of course, once we discovered genetics and it was a simple answer, it explained everything, we forgot about these unusual sort of patterns of inheritance. It didn't fit, it wasn't convenient, and so it's easy to just ignore it. But we're discovering now more and more of these cases where the patterns of inheritance don't fit simple genetics. And so we're having to bring back in these old ideas and look at the possibility that there's multiple modes of inheritance that can influence how variability in offspring occurs.
So that could have all kinds of implications.
It could definitely have all kinds of implications. We find this pattern called missing heritability in medical studies, where you do genome-wide association studies looking for these patterns of inheritance, and there's always a proportion that can't be explained by genetics alone. So I think it's these environmental influences that explain that missing heritability, and now the search is on to try and discover what these mechanisms of non-genetic inheritance are. And I think we're only just starting to scratch the surface.
So that's a big, well, what's the word? It's a big deal for evolution to understand what's happening across the entire environment and history.
It's a big deal for evolution, and it's a big debate. Not everybody is completely convinced, and there's two camps at the moment where you have some people pushing that environmentally acquired traits are inherited and they will influence evolution, whereas the other camp are saying these processes are probably still driven by genetics. This really only becomes a problem when you're looking at long-term evolution. The sort of evolution that I look at is really selection and inheritance. And it's clear-cut that, yes, environmental traits can be transmitted across a single generation and even multiple generations.
And you've won some awards lately.
Thank you. Yes, I have been lucky in winning some awards lately, both the L'Oreal UNESCO for Women in Science Fellowship and the New South Wales Young Tall Poppy Award. So it's really nice to see some recognition for this fundamental science.
What advice do you give to students who'd like to study in your area?
So anyone thinking about having a career in science, it is an amazing opportunity to just be able to follow curiosity or, an exciting idea that gets you excited. It's a real privilege to be able to just have an idea that you can then go and test and find evidence for. It is quite a challenging career, and you do need to have that passion to drive you. And the most exciting thing is you never know where it's going to take you. But it also means that you might need to be open to possibilities of going in directions that you didn't think. So I started my science career because I loved the ocean and I wanted to be a marine biologist. And now I'm working in reproduction. It's not where I thought, but that's what makes it so wonderful, is you follow the ideas and the questions, and it leads you on a journey that you never could have imagined. So if you think that you would like that sort of career, please go for it. We need young, passionate people to help us change the world.
Well, Angela Crean, thank you very much.
Thank you so much, Ian. It's been a pleasure.
That was award-winning evolutionary ecologist Dr. Angela Crean, talking about her discoveries in reproductive biology. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. And now for something completely different. Luke Coffey with his music playing robot. Luke is a final year undergraduate mechatronic engineer at the University of Technology, Sydney. I met him in the busy engineering faculty lunchroom and began by asking him, "Have you built a robot that plays guitar?"
Well, it's not a guitar playing robot, it's a robotic guitar. So essentially what I've done is taken a guitar, ripped it apart in 1,000 different pieces and then put it back together with a bunch of motors around it so that it can play and pluck the strings like a human would.
And how many strings does it pluck?
6 strings.
And can it do chords as well as plucking?
So the way I designed it was I designed a single system to work on one string so that it can both pluck an individual string, and then I copied and pasted that system 6 times so that it can do chords, it can do plucking, it can do a whole range of different things on like a normal human would be able to do on a guitar.
And how does it sound?
Right now it doesn't sound so good. I've currently finished my first prototype. I've had some health issues along the way, so I haven't been able to finish it as good as I would have hoped. But at the moment, it's a good working prototype. It's a bit slow, and I know where the improvements can be made, so it's just a matter of continuing to reiterate so that eventually it will be able to play just like a normal guitarist, and hopefully eventually play through the fire and the flames.
So right now it doesn't sound so good.
Right now it doesn't sound so good. It can play some really slow basic songs, but for a first prototype I'm pretty happy with it.
And what inspired this project?
Originally, probably about a year ago, I was sitting down thinking, what am I going to do for my thesis? Had no idea. Then I was like, music and robots sound fun. So then I just sat down, had a look on YouTube, just saw what was out there, and then I found a thing called Animusic, which is essentially animated musical robots, and it's a company, I think it's based out of America, and they do a whole range of animations. And I saw this one called, I think it was called Resonant Chamber, where it was a giant robot guitar animated, and it looked amazing, and I was like, I want to make that.
And what's controlling the robot?
At the moment, the hardware, so all the motors and actuators on each of the systems is controlled by an Arduino. And then since there's 6 systems, there's 1 Arduino per system. So I've got a Raspberry Pi controlling each of those Arduinos to do all the timing.
So 6 Raspberry Pis and Arduinos.
No, sorry. So 6 Arduinos and 1 Raspberry Pi controlling those Arduinos is like the master.
And what language are you programming it in?
The Raspberry Pi is in C++ and some Python, and the Arduinos is just the Arduino language.
And it's all just on Linux?
The Raspberry Pi is on Linux, and the Arduinos, I've just programmed them on my laptop in Windows.
And how long has it taken you to get this far with the robot?
Well, my thesis is actually a year long, so I technically started about January when I actually started. Probably about 2-3 months to get this prototype. So I wasted a lot of time doing nothing. And I probably could have iterated a couple more times to get a much better prototype if I hadn't have wasted an entire semester. But I probably spent a good 2 or 3 months straight working on it, and this is what I got out of 2 or 3 months work, which is pretty good for a first prototype, so I'm happy with it.
And what do you want to do with it in the future?
In the future, if I can get some funding and to continue to iterate it, I want to take it busking, because who wouldn't want to see a robot busking, to be honest? I'm hoping I've got a few different organisations that might be interested in having it in their foyers, and potentially maybe even kickstart a robot band and go on a tour.
So in your robot band in the future, what other instruments would you roboticize?
Well, I can pretty much roboticize now that I understand any stringed instrument. So I could make bass, electric guitar, piano's pretty easy. I was thinking of doing a piano robot originally, but it didn't seem as interesting to me or difficult compared to a guitar robot. And then drums, which is just bang, bang, bang. So I don't think the drum robot would be too difficult.
And obviously you're a musician before you started the project.
I don't play guitar. I play a little bit of piano, but I'm not actually a musician. So it was quite an interesting experience going from never playing a guitar ever in my life to building something to play it.
Would you learn it? Do you think learning to play it yourself would help you program it better?
Absolutely. And I'm actually going to be learning how to play guitar after I finish my thesis.
Are you going to take lessons, or are you going to do an online course?
I'm just going to do an online course and self-teach. That's how I learned piano, and I'm pretty decent at piano.
Is there anything you'd like to add?
Just for anybody listening out there, if you want to get on board, work on the project, or potentially want to help fund it so you can see the project move forward, just contact Ian, or we'll potentially have a website one day. I don't have one at the moment, but just get a hold of me and we'll see what we can do. I'd love to talk to you guys.
And are there any projects coming up once this is finished, now that your thesis is about done?
For me personally, I'm working on a startup at the moment. I'm still not sure 100% what that is, but I've got a few different engineering projects lined up, and I've got a few different engineering students who I know who are interested in working on them. So just a whole range of different small things that I'm trying to do one at a time. So I've got a little security system that kind of tracks people walking around, a mushroom growing box actually, so I'm really keen on that one. And just a few different little projects like that. I've actually got another musical project I'm thinking of that incorporates a bunch of sensors you put in your hands, and then you can move your hands around and actually create music out of that. So I think that'd be pretty cool to play around with.
Well, Luke, thank you very much.
It was a pleasure being here, and thanks for having me.
That was Luke Coffey and his robotic guitar. Check the YouTube channel for videos of the robot. Speaking of videos, I've once again experimented with sticking a camera in front of an interview recording. The interview can be watched almost unedited on the Diffusion YouTube channel, or you can just wait for the edited version to be broadcast on a future episode. And that's all from us this week on Diffusion. Would you like to hear your voice on radio? Record a voice memo on your phone or use the voicemail tab on the website. We need more people contributing stories to Diffusion. Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. And please do send me an email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Join my patrons in supporting the show at patreon.com/diffusionradio. Sound check was by Charles Willock. I produce Diffusion, which is broadcast around Australia to 27 stations on the Community Radio Network, including 2RBM in the Blue Mountains of New South Wales, 8CCC in Alice Springs and Tennant Creek, 2MVR in Nambucca Valley, and 3MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. If you enjoyed the show, you can explore more than 900 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.